So this is what we left number 76 with. Using the chain rule with product and then the derivative of secant for both terms. So now 7 divided by 7 cancels, 5 divided by 5 cancels. So now that we're multiplying secant to the 6th of x times secant, that would give us secant to the 7th of x tan x minus secant to the 5th of x tangent x. Okay, I'm okay with you stopping here, but if we look to factor, we can factor out of both terms secant to the 5th x tan x. Okay, factoring is dividing out. So if I divide this entire factor from the first term, I'd be left with secant squared x. And then secant to the 5th x tan x divided by itself would leave me with 1. More of a simplified answer. Now this is even, so you wouldn't see it on CalcChat, but I have a squared trig function and a 1 as my second factor. So you should be thinking Pythagorean identity. I need the secant function, so I'm going to divide each of these pieces by cosine squared x. So we can manipulate the Pythagorean identity any way we need to. We get tan squared x plus 1 equals secant squared x. Now getting it to be secant squared x minus 1, subtracting 1 from both sides. The most simplified answer would be this. So, I'm okay with you stopping here. This would get you full credit on a test. This is looking for common factor, and then this is recognizing that you have a trig identity. And then I guess the most simplified answer, then we would have tan cubed of x. F of x equals 3x all over the square root of x squared plus 1. Okay, so let's look at the denominator as x squared plus 1 to the 1/2 power. So to find the derivative, we need the quotient rule. The denominator is going to need the chain rule as well. Bottom function times the derivative of the top minus top times the derivative of the bottom. So deriving something to the 1/2 power, bring the 1/2 out front, subtract 1 from the exponent, and then multiply by the derivative of the inside, all divided by bottom squared. Okay, so we have 3 times the square root of x squared plus 1, negative 3x. These 2's cancel, so negative 3x times x would give us a negative 3x squared, making that exponent positive, all divided by square root of x squared plus 1, and then all divided by x squared plus 1. These are separate from each other. Okay, one fraction. Let's deal with the numerator. My common denominator in the numerator is going to be square root of x squared plus 1. So multiplying this first fraction by square root of x squared plus 1. So I have 3 square root of anything times itself. They undo each other. Minus 3x squared, because the second fraction didn't need a common denominator. Still divided by x squared plus 1. Okay, so let's think about distributing that 3. 3x squared plus 3 minus 3x squared, all divided by square root of x squared plus 1. And now for the denominator, dividing by x squared plus 1 is the same as multiplying by 1 over x squared plus 1. These cancel. If we rewrite this as to the 1/2 power, now in the denominator, notice that you have like bases. So my numerator simplifies to 3. When you're multiplying like bases, add the exponents together. So the denominator would become x squared plus 1 to the 3/2 power. And that would be your derivative. Y equals cosine of the quantity x minus 1 divided by x minus 1. So again, quotient rule, bottom times the derivative of the top. Now if we looked at cosine of x minus 1, working from the outside in, derivative of cosine is negative sine of what follows it times the derivative of the inside. Minus top function, oops. So minus top function times the derivative of the bottom, which is 1, all over bottom squared. Okay, so we have a negative out front, x minus 1 times sine of x minus 1 minus cosine of x minus 1. All divided by bottom squared. And that's all you can do. These x minus 1s don't cancel because they're attached to the trig functions. You have an x minus 1 here, but you can't get rid of it because there's no x minus 1 term in the second term. So this is the final answer. Might not look nice, but don't simplify anything else. (82) f of x equals the cube root of x squared minus 1. It says find the derivative of the function at the given point. So let's rewrite the function as x squared minus 1 to the 1/3 power. So the derivative, coefficient out front, x squared minus 1 to the negative 2/3 power times the derivative of the inside, which is 2x. So writing this with a positive exponent to the 2/3. So that's our derivative. Now we want to find the value of the derivative at 3. So replacing the x's with 3. These 3's will cancel. Remember, you don't have a calculator, so looking to simplify anything possible. But 2 times 3 is 6. 6 divided by 3 would give us the 2. Then we have 9 squared minus 1 would give us 8 to the 2/3 power. Okay, so the 2/3 power, remember rational exponents, power over root. So I have 2 all over the cube root of 8 to the second power. Cube root of 8 is 2. 2 squared would give me 4. So the derivative would be 1/2. Now, a natural consequence of this, write the equation of the tangent line. Y minus 2 equals the slope times x minus 3. The directions don't ask for that, but that needs to be able to be done if you're asked to find the derivative at a point. (84) Y equals cosecant of 3x plus cotangent of 3x at the point pi over 6, comma 1. So the derivative, working from the outside in, derivative of cosecant is negative cosecant cotangent times the derivative of 3x, which is 3, plus, working from the outside in on the second term, derivative of cotangent is negative cosecant squared of the function times the derivative of 3x, which would give us 3. So now we have negative 3 cosecant of 3x cotangent of 3x minus 3 cosecant squared of 3x. So now we want the derivative at pi over 6. So wherever we see an x, we'll replace it with pi over 6. 3 pi over 6 will reduce to pi over 2. Pi over 2 is up here on our unit circle. The coordinates at that point are 0, 1. So the sine is 0 at pi over 2. Cosine is 0 at pi over 2. Sine is 1. -3. Cosecant's the reciprocal of the sine function. The reciprocal of 1 is just 1. Cotangent is the reciprocal of the tangent function. Up here, okay, so tan of pi over 2. Sine over cosine. The tangent's undefined. But when we take the reciprocal of that, the cotangent is equal to 0. So cotangent of pi over 2 is 0. -3. Cosecant of pi over 2 is 1. And then we'll square that value. So 0 minus 3. -3 is the value of the derivative at pi over 6. Again, this is the final answer for the question, but writing the equation of a tangent line, y minus 1 equals -3, x minus pi over 6. (94) y equals 1 over x plus tan x. You're asked to find the second derivative. So let's rewrite this as a power rule. First derivative, -1 x to the -2nd power plus secant squared x. So you don't need to write the first derivative with a positive exponent because your ultimate goal is to find the second derivative. So I rewrote secant squared as the quantity secant x squared. So y double prime using my power rule, bring the exponent down, subtract 1 from the original. Now using chain rule, deriving something being squared, 2 times that something to the first power times the derivative of the inside. So we get 2 over x cubed plus 2 secant squared x tan x. Positive exponents. You don't need to worry about one fraction because it doesn't involve a radical. So that would be our final answer. 96, y equals sine squared of x. Again, find the second derivative. I'm going to rewrite this function as sine of x quantity squared. First derivative using the chain rule. Bring the 2 out front, subtract 1 from the original. Derivative of sine is cosine of x. Now for the second derivative, we're going to need the product rule. 2 is a coefficient, that's going to remain, and we're just going to multiply our derivative by that. Product rule, first function times the derivative of the second function. Derivative of cosine is negative sine. Plus second function times the derivative of the first function. Derivative of sine is cosine. Again, 2 is just our coefficient. Negative sine squared plus cosine squared of x. I'm good with you stopping here, but we've seen this several times. If I rewrote this as cosine squared minus sine squared, that's our identity for cosine of 2x. Again, it's even. You wouldn't check it on CalcChat, but that would be the most correct answer, but you can stop there.